Welcome to the deep dive. Today, we're jumping into something really critical, especially if you're working in the cloud-native space with sensitive workloads. We're talking security, compliance, specifically FIPS 140-3 compliance. It sounds technical, and it is, but it's essential. So our mission really is to unpack how you can actually achieve this robust FIPS compliance for Amazon EKS clusters. We'll be looking at, well, a pretty powerful combination, Bottlerocket OS and AWS Key Management Service, KMS. And the key thing here is how this approach takes something that used to be, frankly, a massive headache, very manual, complex, and makes it way more manageable. This is need-to-know stuff if you want to get serious about cloud security, or maybe you're prepping for a technical interview, right? This deep dive will definitely help. Let's get started. Okay, so FIPS 140-3. I mean, it sounds like heavy-duty government regulation, maybe a bit intimidating, but fundamentally it's about strong cryptography, yeah. Making sure encryption is top-notch. Could you maybe break down what FIPS 140-3 actually means for us and why it's such a particular challenge when we talk about EKS clusters on AWS?
Absolutely, yeah. It can sound like jargon, but you're right. It boils down to strong crypto. FIPS 143 is basically the latest US government standard for cryptographic modules. So think hardware, software, anything doing encryption. It sets really strict requirements for how they need to be designed and implemented to protect sensitive info. It updates the required algorithms, the math behind the encryption, and really ramps up the physical security specs for the hardware modules. And its impact, well, it touches everything. Hardware, OS, software, the whole stack. Now, for Amazon EKS AWS's managed Kubernetes service, getting FIPS 143 compliant is definitely a specific challenge. It's not just one thing. You've got to coordinate across, well, multiple pieces. The OS underneath needs compliant crypto modules. Your container runtime needs to be secure. All your network traffic, internal and external, needs encryption using validated methods. And critically, your key management system, how you handle your encryption keys, that also has to meet these really high standards. Traditionally, getting this right meant heaps of manual setup, complex configurations everywhere, and then the constant pain of validating it all over and over. So yeah, our goal today is to kind of demystify that whole process.
Right. Okay. That makes sense. It's a whole system problem. So let's unpack that simplification you mentioned. Our sources really highlight Bottlerocket FIPS AMIs as being a game changer here.
Yeah.
Thinking about setting up hundreds of worker nodes manually for FIPS. Yeah, that sounds awful. How exactly does Bottlerocket make this easier on EKS? What does it actually take off the table?
Yeah, awful is probably the right word for the old way. Bottlerocket FIPS variants, they really are the most streamlined path for the OS level. So Bottlerocket itself, it's this purpose-built Linux OS from AWS just for running containers. Minimal, secure. The FIPS variants are specific AMI's machine images that come, preloaded and pre-configured with FIPS-validated cryptographic modules.
Yeah.
Straight out of the box. We're talking things like the Amazon Linux 2023 kernel crypto API cryptographic module and the AWS LC cryptographic module. They're already in there, validated, ready to go.
Okay, pre-validated. That sounds key.
Exactly. Think about the alternative. Manually compiling crypto libraries, validating them, setting kernel parameters, ensuring every update doesn't break compliance across potentially thousands of nodes. It's a nightmare. Bottlerocket just eliminates that. The big advantage is you basically skip most of that manual OS level FIPS configuration. For instance, that FIPS1 kernel flag you need. It's set by default in the FIPS AMI. The modules are pre-validated, like I said. And another neat thing, AWS service endpoints, they automatically resolve to the FIPS compliant versions when you use these AMIs, so less network config hassle. When you set up your EKS cluster, maybe using HTTL, you just specify AMI family. Bottlerocket and point to the right FIPS AMI using its SSM parameter path. You'd also typically flip a switch conceptually like not use FIPS endpoint.true. It makes sure everything talks to the FIPS endpoints, so your nodes are FIPS ready the moment they launch. It's a huge leap. Really cuts down on manual work and, frankly, human error.
That's massive. It really shifts that compliance burden from the engineering team onto the OS itself, doesn't it? But okay, the OS is sorted. What about the keys? The actual cryptographic keys, that's always central to security. Even with a FIPS OS, managing keys correctly is critical. Our sources point strongly to AWS KMS. What's its role here, and how does it meet the FIPS 143 standard?
Absolutely central, you're right. KMS is the core piece for key management in this picture. So KMS, Key Management Service, it's AWS's managed service for creating and controlling your encryption keys. Makes it much easier than managing your own key infrastructure. Now for FIPS, the really crucial part is the hardware underneath KMS. The hardware security modules, or HSMs, that KMS uses, they've achieved FIPS 143 Security Level 3 certification.
Level 3. What does that actually mean in practice?
Good question. Level 3 means these HSMs are highly tamper-resistant physical devices. They're designed specifically to store keys securely and perform crypto operations within a secure, validated boundary. It provides strong protection against physical tampering and ensures robust cryptographic operations. And here's a key benefit. Achieving this Level 3 certification with the managed KMS service often means you don't need to deploy and manage your own separate dedicated CloudHSM cluster, which historically was often the only way to get that Level 3 assurance in many regulated sectors.
Oh, okay. So it avoids needing those dedicated, often expensive and complex CloudHSM boxes.
Exactly. Setting up and running CloudHSM involves significant operational overhead and cost. KMS achieving this certification is a big deal. It means you can use a fully managed, globally available service for your high-security key management needs. What might have been a complex project becomes, configuration settings and API calls. Huge simplification and potential cost saving. Integrating it with EKS for FIPS is pretty straightforward too. When you set up encryption for things like Kubernetes secrets, you configure EKS to use the specific FIPS-compliant endpoint for KMS. You'd see this in the encryption configuration for EKS, explicitly pointing to something like KMS fips.us-gov-1.amazonos.com. This ensures that whenever EKS talks to KMS to encrypt or decrypt secrets, it does so using that FIPS-validated pathway and hardware.
Okay, so Bottlerocket handles the OS layer, making nodes compliant out of the gate. KMS provides FIPS Level 3 validated hardware security for the keys, simplifying that whole aspect. That covers two big foundational pieces. But you mentioned FIPS is about the whole stack, right? End to end. What other configurations are really crucial to get right across the entire EKS cluster beyond just the nodes and the keys themselves?
Right, exactly. Those are foundational, but FIPS demands you look at every layer. This is where the deeper configuration comes in. First, even with Bottlerocket FIPS AMIs handling some automatic endpoint stuff, you might need to explicitly configure other AWS services or internal components to use their FIPS endpoints. So you'll want to verify this. You can check the Bottlerocket settings. There's an API call, epiclientgetsettings.aos, to make sure use FIPS endpoint is set to true. And crucially, you need to validate that FIPS mode is actually enabled inside the container runtime environment on the nodes. A quick check like cat proxy scripto FIPS enabled should return 1. You need to confirm it's active.
Got it. Verify, verify, verify.
Precisely. Then there's your network edge, your load balancer, and ingress controllers. If you're using application load balancers, ALBs, for handling incoming traffic and terminating TLS, the secure connection.
Yeah, the padlock icon stuff.
Exactly. ALBs can now perform that TLS termination using FIPS 143 validated cryptographic modules provided by AWS libcrypto. So in your Kubernetes ingress definition, you'd specify a particular security policy like al.ingress.kubernetes.iosl-policy. ELB security policy TLS 1312 FIPS-S 2023-04. That tells the ALB use only FIPS-compliant TLS. Makes your front door compliant too.
Okay, now this next one is really critical and sometimes overlooked. Your application containers themselves, they must use FIPS-validated crypto libraries. Ah, so it's not enough for the OS to be FIPS. The app inside the container has to be too.
Absolutely. This isn't automatic. You need to be really deliberate here. It starts with choosing the right base image for your Docker file. Something built on a FIPS-enabled OS, like public.ecr.os Amazon Linux.2023-FIPS. Then, inside your Docker file, you need to install FIPS-validated versions of libraries your app uses for crypto, like OpenMetFIPS. And importantly, you often need to set environment variables within the container, things like env OpenSSL FIPS1 or env JogoCrypto FIPS1, depending on the libraries. This tells the application code to actually use the FIPS mode of those libraries. If your app is doing its own crypto using non-validated modules, you've got a hole in your compliance.
Wow, okay. That requires careful application packaging.
It does. And finally, network communication within the cluster. FIPS extends there too. You should be using Kubernetes network policies to strictly enforce encrypted communication for sensitive data flows between your pods or services. For example, a policy might say traffic between service A and service B must use TCP on port 8443, for internal HTTPS maybe, and block other ports or protocols. Think of them as internal firewalls ensuring secure paths.
Okay, that paints a much fuller picture. OS, keys, ingress, the containers themselves, and internal network traffic. It really is end-to-end. So let's say we've done all this configuration. It sounds incredibly thorough, but what about running this day-to-day? In the real world, how do we actually prove we're compliant? How do we monitor it constantly? What about the costs? Does this FIPS stuff add up? And disaster recovery? How does that work for a FIPS cluster?
Yeah, the operational side is just as important as the setup. Great questions. So, quick summary first. FIPS isn't set and forget. It needs ongoing validation across all layers, robust monitoring for any configuration drift, smart strategies to manage the potential extra costs, and yes, specific DR planning.
Diving deeper for validation, FIPS 133 demands continuous proof. Bottlerocket actually helps here with its reporting API. You can run a command like Bottlerocket report format JSON report FIPS on a node, and it spits out detailed JSON confirming FIPS status. It'll show FIPS sendable true, kernel FIPS, one gap, and the status of those specific crypto modules we mentioned earlier. It gives you concrete evidence. Okay, so automated checks are possible. That's good.
Definitely. For monitoring configuration drift, making sure nothing accidentally gets turned off, you need automation. You can use CloudWatch custom metrics to track key things, like that proxys stripto FIPS sendable value, or whether settings.as.use FIPS endpoint is true. You could also set up alerts, maybe using Prometheus if you use that, to fire immediately if, say, FIX mode gets disabled on a node or an endpoint flips back to non-FIPS. Proactive monitoring is crucial. Now, cost. Let's be honest. Yes, FIPS compliance can add some operational cost. You're using specialized AMIs, maybe hitting dedicated FIPS endpoints, which might have slightly different pricing or routing, and you're likely doing more intensive monitoring.
So how do you manage that?
You optimize strategically. For the EC2 worker nodes, consider using spot instances for workloads that can handle interruption. FIPS doesn't preclude spot. For KMS, if you have very high key usage, look into client-side caching strategies where appropriate and secure to reduce the number of direct API calls. Think about data transfer costs, keep compute and data close. And be smart about CloudWatch metrics, only collect what you truly need for compliance and ops. It's about being efficient. And finally, DR and HA. For a FIPS cluster, you need to ensure resilience. That means running your EKS node groups across multiple availability zones like USGov West 1A, 1B, 1C. Standard HA practice, but vital. And if you back up data or config across regions, those backups also need to be FIPS compliant. So when you configure the backup, you must ensure it uses a FIPS KMS key for encryption. Explicitly tell your backup tool to use a FIPS key, maybe specifying FIPS endpoint. True for the KMS interactions during backup. Got to maintain the standard everywhere.
That operational perspective is super helpful. Validation, monitoring, cost optimization, DR, all critical. But, even with the best plans, things go sideways sometimes. What are some common trip-ups or issues people run into when they're implementing FIPS 143 on EKS? How do you even start debugging when something breaks? And the performance question. Does all this heavy-duty encryption slow things down noticeably?
Yeah, troubleshooting is definitely part of the game. And performance is always a fair question. Quick take. Common issues involve network connectivity to FIPS endpoints, getting container images right, and app library clashes. Debugging requires checking connectivity inside containers and Bottlerocket settings. And yes, there's a performance impact, but it's usually predictable and manageable. So, common problems we see. Sometimes getting connectivity to the FIPS endpoints, like for ECR, the container registry, can be tricky, especially from private subnets with strict network rules. That needs careful network configuration. Ensuring container image compatibility is another big one. Making absolutely sure the image uses the right base, has the FIPS libraries installed, and the app is actually using them via those environment variables. It's easy to miss a step there. And sometimes you might hit subtle conflicts where an application library just wasn't designed or tested with a FIPS-validated version of OpenSSL, for example, and behaves unexpectedly.
Okay, so how do you diagnose those?
You need the right tools. For connectivity, basic things like inks lookup ekr-fips-gov-west-1.amazonoz.com from within the cluster can tell you if DNS resolution is working. To check inside a container, you can docker exec or kubectl exec into it and run commands like openSSL version, a grep FIPS, to see if OpenSSL reports itself in fix mode. And for Bottlerocket itself, using API client get settings jkey.e says can quickly show you if it's configured correctly for FIPS endpoints. Now, performance. Yes, FIPS crypto operations do add overhead. It's unavoidable. You might typically see, say, a 5 to 15% increase in CPU usage because the FIPS-validated algorithms are often computationally heavier. Memory usage might go up maybe 10 to 20% to load those specific FIPS libraries. Network latency could see a small bump, maybe 2 to 5 milliseconds extra just for routing through the dedicated FIPS endpoints. And storage encryption might be slightly slower, perhaps a 3 to 8% reduction in throughput.
Okay, so noticeable, but maybe not catastrophic if you plan for it.
Exactly. It's usually manageable, but you need to account for it. This really raises that important question for anyone designing these systems. How do you balance these strict security needs with your performance targets and operational efficiency? It often means maybe sizing your instances slightly larger or being more aggressive with auto-scaling configurations to absorb that overhead and still meet your SLAs. It's a trade-off you have to actively manage. So just to wrap things up, Implementing FIPS 143 on EKS using Bottlerocket and KMS, it really does offer a much more streamlined, robust way forward, especially for those federal or highly regulated workloads. Bottlerocket FIPS AMI/the OS setup complexity. KMS with its level 3 HSMs avoids the need for dedicated CloudHSM, simplifying things and saving costs. But success really depends on getting a few things right. Comprehensive validation, making sure your container images are compliant, enforcing network policies, continuous monitoring, and actively managing that performance trade-off. Getting this architecture right lets organizations meet those really high bars, FedRAMP High, TOD, IL5, while keeping things relatively simple and cost-effective in the cloud-native world.
That was a fantastic deep dive. Really practical insights into a complex area. So a final thought for you, our listener. Even if FIPS isn't a direct requirement for you today, what parts of your infrastructure might benefit from thinking about this level of cryptographic compliance? How could understanding these stricter standards actually help improve your overall security posture anyway? Something to think about.
That's all for this topic. Stay tuned for the next DevOps Cloud interview question.